Hello everybody, what's up? This is the next part and happy sciencing. Of course, happy sciencing. Science is everything in this world, I know. So I'm trying to spread knowledge. So now this is the next part of what I told in my previous video. The next part of work power energy explaining the concept of conservation. So in conservation, I don't have any notes, I don't have any paper for it because any paper can't explain you the actual meaning of conservation until I solve any problems on it. So just for theory's sake, just for God's sake, just for science sake, let me tell you some of these silly asshole formulas. The first formula can be called as work energy theorem. It's a theorem, so of course it's theorem, so it's work energy theorem. Come on. Work energy theorem. What does it say? That network equals to kinetic energy finals minus kinetic energy initials, that is equal to delta K, kinetic energy change. Now I know you would say, why did I say it's complicated? Why did I say it's quite difficult by seeing just this formula? This formula is quite easy, but while applying this formula, you know what, our asses turn red. Yes. Now let's see another formula, another boring formula. So that is delta K equals W net. I'm writing this formula again in some another manner. Delta K, that is change in kinetic energy, equals network equals WC plus WNC plus WOTH. One of the most important formulas. Now let me tell you what does each thing stands for. That is WC equals to work done by conservative forces. WAC, same thing, non-conservative forces. WOTH, other work. I don't know the actual definition or actual meaning of other work, but anything which is not conservative or non-conservative is other. And of course, as according to the other formula, as I said, dW equals minus of du. dW is work done by conservative forces. Yes, it's work done by conservative forces, so dW equals minus du. Then we can just write that equation again as work done by non-conservative plus work done by others equals to change in kinetic energy plus change in potential energy. That is change in mechanical energy. Oh, I'm so sorry. Change in mechanical energy equals to work done by non-conservative force plus work done by other sources. That's the actual meaning. Wow. And you know what? It's the only thing I've got about the conservation of forces. It's the only thing that the conservations tell us. And all the other things conservations tell, which is actually very important, comes in problems which we solve. So let's recap. Work energy theorem tells us work net is change in kinetic energy. Change in kinetic energy is work net, which is work of conservative plus work of non-conservative plus other works. Change in work equals to minus change in energy, where change in work is work done by conservative forces, and work by non-conservative plus work on others equals change in kinetic plus change in potential by the formula. Now let us solve some shitty asshole problems, shall we? Okay. So guys, here we have a problem. Question number 1. And guys, please believe me or not, it's a bullet. Yes, it's a bullet. I'm very, very bad at drawings. I'm extremely sorry for that. Yes, I am sorry, please. So at first, let me explain you the question. A bullet is fired from a gun. As you can see by my very worst drawing, it is penetrating through a plank 1 with a velocity v. It hits the plank 1, goes through the plank, and loses the 1/5 of the velocity so that its remaining velocity becomes 4v by 5. And after hitting another plank, it just comes to rest at the end of the plank. The thickness of first plank is T1, the thickness of next plank is T2. R is resistance offered by the planks, that is the plank resistance, the resistance offered by the materials of the plank, anything. So what is the ratio of the thickness? What is the ratio of the thickness? Now here let us apply this formula. You know which one? This. Work net equals to change in kinetic energy. My marker is down. Let's do by pen. So dw equals to dk. So for first plank, change in kinetic energy equals half into mass v square minus half into mass 4 by 5 times v square. Half mv square minus half of mv square. I hope you understand the question. It's going up. So half of mv square minus half of m4 by 5 v square, that is v1 and this is v2. That is before going through plank and after going through plank. And what is work? Come on, dw equals to, here the resistance offered by the planks acts as the force. So what is work? Work equals to r t1. R times t1 is the work. So let's equate it afterwards. For let's calculate dke, which is equal to half of m v square minus 4 by 5 v square. Come on, I'll have to equate it. Equals half of m times 5v square minus v4v square upon 5v upon 5. Oops. It should be 16 upon 25v square. I'm sorry. So half of m into 25v square minus 16v square upon the whole 25, that is change in kinetic energy equals half of mv square 9 upon 25. As change in kinetic energy equals work, this whole thing equals to r times t1. Let me take it in a box and let me name it as equation 1. Alright, for first plank. Now let's do it for second plank. Again doing the conservations, that is for second plank. For second plank, the first velocity would be 4v by 5, that is the approaching velocity, and the leaving velocity would be 0. So applying this whole fucking thing for the second plank, half of m 4 by 5v the whole square minus 0, because velocity is 0 because the bullet stops at the second plank, equals to r times t2. That is the force applied by the second plank on the bullet, the resistance into the thickness of the second plank, that is t2. So equating this whole thing, we get half mv square into 16 upon 25 equals to r times t2. Let me take it in a box again. It's our second equation. Now what to do? We have our first equation, we have our second equation, and what do we have to find is T1 upon T2. So let's do something, let's divide. Dividing 1 by 2. Half mv square, half mv is cut. R and R gets cut. 9 upon 25 upon 16 upon 25 equals T1 upon T2. Therefore, we get the answer T1 upon T2 equals 9 divided by 16. So that's how we got the answer. What did we did? We just calculated the change in kinetic energy, which is half mv square, half mv1 square minus half mv2 square. v2 is final velocity, v1 is initial. For first Planck, we have the force of Planck as the force applied by the Planck to the bullet, resistance applied into the thickness, that is fx cos theta. Cos theta would be 1, so fx. So, and for second Planck, half mv square again, but the bullet takes the rest on the second Planck, so velocity 2 equals 0. Equating the all, dividing, we get T1 upon T2 equals 9 upon 16, which is the correct answer. So guys, I hope this much is okay for today. I'll solve more. Okay, I'm solving more questions, but today the video is now quite long. I don't want to bore you with my long videos, but if you want that, then you can comment. By your request, I can make any videos for you. And yeah, if you find this video a bit informative, then do like and subscribe my video, and of course subscribe my channel, of course, and like my video. And please, what type of video do you want, what type of lecture should I give, whatever should I improve, please tell me in your comments. I would read them. I would really feel my pleasure. Even if you would criticize me, I would feel it my pleasure. So please comment in the video how should I improve my video, then I should earn your subscription and like. So thank you guys, see you in my next session. Next session I will be explaining circular motions. So bye for now.